Hi guys, so today we're going to be doing identity and inverse matrices. So let's get started by defining what an identity matrix is. Okay? So for matrices, the identity matrix is a square matrix, so it has the same rows and same columns, that when multiplied by another matrix, it equals that same matrix. Okay? So this here is the 2 by 2 identity matrix. This is the 3 by 3 identity matrix. And what you should see here is that all other things are 0, but that main diagonal is filled with 1. The identity matrix for multiplication. The identity matrix for multiplication, signaled by a capital I, is a square matrix with 1 for every element of the main diagonal, starting from the upper left all the way to the lower right, and 0 in all the other positions, which is why you see that here in the 2 by 2 one and the 3 by 3. Okay? So we can know that two square matrices, n by n, matrices are inverses of each other if their product, when we multiply them, it results in an identity matrix. Okay? So we're going to start with example 1 by verifying identity matrices. Okay? So here's the first one with A. Okay? So they're going to be an identity matrix. When I multiply them, I get the identity. They're inverses if they result in the identity. Okay, so the first thing I'm going to do is I'm going to multiply x and y together. Okay, so that is 2, 2, negative 1, 4, multiplied by 1 half, 1 half, negative 1, and 1 4. Okay, so equals, let's multiply here. So we're going to do row and column, so that means 2 times 1 half plus 2 times negative 1. So I did this row and this column. Okay? I will simplify it later. Okay? Then same thing, same row, but the second column now. So 2 times 1 half plus 2 times 1 fourth. Okay? Then I'm going to do the second row and first column. Okay. So negative 1 times 1 half plus 4 times negative 1. Okay. Then I'm going to do same thing, this row and this column. So negative 1 times 1 half plus 4 times 1 fourth. Okay. So let's simplify here. 2 times a half is 1. So far, so good. Plus negative 2. 2 times 1 half is 1. 2 times 1 fourth is 1 half. So this becomes 1 plus 1 half. Negative 1 times 1 half is negative half. 4 times negative 1 is negative 4. And then last one here, negative 1 times 1 half is negative half. 4 times 1 fourth is 1. Simplify that. 1 minus 2 is negative 1. 1 plus 1 half is 1 and a half. Negative 1 half minus 4 is negative 4 and a half. And negative half plus 1 is half. Because it didn't result in the identity matrix, right, where it's 1, 1, and then the others are zeros, they are not inverses. Not inverses. Okay. So let's see if P and Q are inverses of each other. Okay. So I'm going to start by multiplying P and Q together. So then 3, 1, 4, 2, multiplied by 1, negative 2, and 3 half. Okay. So we're going to start with this row and this column. So 3 times 1 plus 4 times negative 1 half. Okay. And first row, second column now. 3 times negative 2 plus 4 times 3 half. Okay. And second row here, first column. 1 times 1 plus 2 times negative 1 half. And then second row, second column, 1 times negative 2 plus 2 times 3 halves. Okay? So 3 times 1 is 3. 4 times negative half is negative 2. 3 times negative 2 is negative 6. 4 times 3 half is 6. 1 times 1 is 1. 2 times negative half is negative 1. 1 times negative 2 is negative 1. And then, negative 2. And then 2 times 3 halves is 3. When I simplify it, 3 minus 2 is 1, negative 6 plus 6 is 0, 1 minus 1 is 0, negative 2 plus 3 is 1. Right? And so it worked. This is the identity matrix, right? 1 along the main diagonal and 0 on the others. Now I just check in for QP. Okay. Now I'm going to do Q first. So 1, negative 1 half, negative 2, 3 halves, times 3, 1, 4, 2. Hopefully there's room. Right. So starting with this first row and first column. So 1 times 3 minus 2 times 1. Then first row, second column, 1 times 4 minus 2 times 2. Then second row, first column, negative 1 half times 3 plus 3 half times 1. And then second row, second column, negative 1 half times 4 plus 3 half times 2. Right? Then this simplifies to be 3 minus 2, so that's 1. This is 4 minus 4, so that's 0. This is negative 3 halves plus 3 halves, so that's 0. And then this is negative 2 plus 3, which is 1. Results both in the identity matrix, so they are inverses. Okay, so why don't you try check your progress 1 and see if they're inverses, and come check your answer when you're done. Okay, for check your progress 1, you should have gotten that they were inverses. If you got that, you can move on to the next one. If not, here is your explanation. So inverse matrices, when multiplied together, they result in the identity matrix. So to check if they're inverses, I had to do x times y and y times x. Right? So then I just multiplied the matrices together, right, starting with first row, first column, and then first row, second column. Then I did second row, first column, and second row, second column. Okay. Then I multiplied, and then simplified. 4/3 minus 1/3 is 1, negative 2. Sorry, this should be negative. Hold on. Negative, so this is 1. Hold on. So this should be negative 2/3, my bad. Plus 2/3 is 0. And then 2/3 minus 2/3 is also 0. And then this becomes negative 1/3 plus 4/3, and that is 1. Okay. Then I repeated it for y and x. So first row, first column. Okay. And then first row, second column. Then I did second row, first column here. And second row, second column here. Okay. Then I did my multiplication. And then I simplified. So 4/3 minus 1/3 is 3/3, which is 1. Negative 1/3 plus 1/3 is 0. 4/3 minus the 4/3 is 0. And negative 1/3 plus 4/3 is 3/3, and 3/3 is 1. Okay. Since both of these resulted in the identity matrix with 1 along the main diagonal and 0s everywhere else, they are inverses. Okay, so now we're going to talk about actually writing the inverse of the matrix. Okay, we're only going to be doing it for the 2x2 matrix. Okay. So the inverse of a 2x2 matrix, note that if A is the main matrix, A to the negative 1 power, or we call it A inverse, written like this, would be 1 over the determinant, which we know is AD minus BC, multiplied by, so this would become a scalar. Okay. What we do is the A and D switch places, and then the B and C change signs. Okay. So again, like I said earlier, notice that AD minus BC is the determinant for that matrix, determinant of A. Okay. Therefore, keep in mind that if the value of your determinant for your matrix is 0, that would be 1 over 0, which we know as undefined, and as a result, that matrix will not have an inverse. Okay, so let's get started. Okay. So we're going to start by finding the inverse of the matrix. So it's going to be 1 over the determinant, and remember the determinant is AD minus BC for a 2 by 2, so that will be negative 4 times 6, minus B is negative 3 here, times C, which is 8. Right? Focus. Then, what we're going to do is we're going to switch A and D's places. So 6 is going to be here now, and negative 4 is here. And then B and C are going to change signs. So negative 3 turns into a positive 3, and this positive 8 now turns into a negative 8. Okay, so now let's just simplify this scalar that's going to be multiplied. Okay, so negative 4 times 6 is negative 24. Minus a negative is plus, so this is going to be positive 3 times 8, which is positive 24. Right? And then here, what you see now is that negative 24 plus 24 is 0, which would make this part undefined, which means that it has no inverse for this one. The matrix R has no inverse because the determinant is 0. Okay. So then let's try P. Okay, so we're going to find the inverse of it. We're going to start with our determinant. So 1 divided by, the determinant is AD minus BC, so 3 times 2, minus B is 1 and C is 5. Okay. Then the matrix part here, A and D are going to switch places, so 2 is going to be here and 3 is here. And B and C are going to change signs. So this is going to be negative 1 and this is going to be negative 5. Okay, so then let's simplify here. 3 times 2 is 6. Negative 1 times 5 is negative 5. Okay. 6 minus 5 is 1, so this is just 1 over 1. Okay. 1 divided by is just 1, so 1 times anything is itself. So the inverse matrix will look like this. And here's my answer. I'm just going to highlight it so you can see. Okay. So why don't you try 2A and 2B on your own and then come check your answer when you're done. Okay, for CYP 2A, you should have gotten negative 4/5, negative 7/5, negative 1/5, and negative 3/5. And for 2B, your inverse matrix should be 3/10, negative 1/10, 2/5, and 1/5. And that's because of the simplified fraction there. Okay, there you go. Okay. If you got it right, you can move on to our next and last example. If not, here's your explanation. So for a 2 by 2 matrix, it's going to be 1 over the determinant here, which is AD minus BC, so AD minus BC. Okay. Then for the matrix part that we're going to multiply, A and D are going to switch places, which is why negative 4 is here and negative 3 is here. And then B and C change signs, so that's why it's negative 7 and negative 1. Okay. Then I just simplified my determinant. Negative 3 times negative 4 is 12. Negative 7 times 1 is negative 7. 12 minus 7 is 5. So 1/5 here. Multiply each of these elements by 1/5, and I get negative 4/5, negative 7/5, negative 1/5, and negative 3/5. 2B is the same thing, so 1 over A times D minus B times C. Right. Then for the matrix part, A and D are switching places, so 3 here and 2 here. And B and C are changing signs, so that's why it's -1 and +4. Okay. Then I'm going to simplify the scalar here. So 2 times 3 is 6. -1 times -4 is +4, and 6 plus 4 is 10, so 1/10. So then multiply each element by the scalar of 1/10, so this becomes 3/10, -1/10. This would be 4/10, which simplifies to 2/5, and then this would be 2/10, which simplifies to 1/5. Okay, so now let's move to example 3. Right. So what we can do with matrices is that we can code messages and decode messages to send secret messages to people. Okay. So here, what we're going to do is we're going to code the message. The message is going to be go tonight. With this matrix, 8 equals 2, 1, and 4, 3. Okay. So the first thing we're going to do is we need to assign each of these, the go space and the tonight, different numbers. Right. So G here is going to be 7. O is going to be 15. The space here is going to be 0. Separate it. Ooh. The T is going to be 20. The O is 15. N is going to be 14. I is going to be 9. G is 7. Which makes H 8. And T is 20. Okay. So here, we're going to code it. Right? So if this is a 2 by 2 matrix, right, in order to code it so that way we can multiply, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers here, or 10 of our letters or spaces here. So then I need to separate it so that way it would work. So I'm going to make this into a 5 by 2. Right? Because if we remember, in order to multiply, right, the inner ones have to match. Right? So that's why. So the only way to fit all 10 to be multiplied, it has to be a 5 by 2. Okay? So what I'm going to do is I'm going to write them in order. So it's going to be 7, 15, 0, 20, 15. So GOTON. And then I. Hold on. Sorry, wrote them the wrong way. It's going to be this way. So G O space T O N I G H T. Okay. Go tonight. G-O space T-O-N-I-G-H-T. Okay. Go tonight. And we're going to multiply it by this coding matrix. 2, 4, 1, 3. Okay. And then now, let's simplify. Okay. So it's going to be row times column. Okay. So row times column. So 7 times 2 plus 15 times 4. Okay. Then the next one now is going to be row column now. So 7 times 1 plus 15 times 3. Okay. Then I'm going to do my next row and column. So 0 times 2 plus 20 times 4. Okay. Same row now, second column. 0 times 1 plus 20 times 3. Okay. Then next row in this column. So 15 times 2 plus 14 times 4. And same thing here. 15 times 1 now, plus 14 times 3. Okay. Fourth row, 9 times 2 plus 7 times 4. And then same row, and now the second column, 9 times 1 plus 7 times 3. And then last row, first column, 8 times 2 plus 20 times 4. And then last column, 8 times 1 plus 20 times 3. Okay. So then let's simplify. This is 14 plus 60. Right? So that gives me 74. This is 7 plus 45, which is 52. Okay. This is 0 plus 80, so that's 80. This is 0 plus 60, so this is 60. This is 30 plus 56, that's 86. This is 15 plus 42, that's 57. Okay. This is 18 plus 28, so that is 46. And this is 9 plus 21, so that's 30. And then 16 plus 80 is 96, and 8 plus 60 is 68. Okay. So this here is my coded message. Okay. So now, if I want to decode it, what I have to do is I need to find the inverse matrix. Okay. So I'm going to use the inverse matrix of A, known as A inverse, to decode it. Okay, so what I'm going to do is I'm going to find the inverse of this. So this is going to be 1 over A times D, so 2 times 3, minus B, which is 1 times C. Okay. Then I'm going to switch A and D's place. So that will be 3 and 2. And I'm going to switch the sign of the 1 and 4. So -1 and -4. Okay? Then I'm going to simplify this. 2 times 3 is 6. -1 times 4 is -4. Okay? This becomes 1/2. Okay? So then my inverse, A inverse, here is going to be -3/2, -1/2. Half of -4 is -2, and half of 2 is 1. So this is my inverse matrix. Okay. Now, what I'm going to do is I'm going to take my coded message and multiply it by my inverse to decode it. Okay. So let's zoom out a little. Okay. I'm going to do in another color, especially since my pen is dying. So we're going to do 74, 80, 86, 46, 96, 52, 60, 57, 30, 68. And we're going to multiply it by A inverse to decode. So we're going to multiply it by -3/2, -1/2, -2, and 1. Okay. I need more space later. Okay, so starting with this row in the columns. So 74 times -3/2 plus 52 times -2. Okay. Then I'm going to do this row, this column now. So 74 times -1/2 plus 52 times 1. Okay. Next row and then the columns. So 80 times -3/2 plus 60 times -2. Then again, same row, but next column now. 80 times -1/2 plus 60 times 1. The next row in the columns, 86 times negative 3 halves plus 57 times negative 2. Same row now, the next column, 86 times negative 1 half plus 57 times 1. Okay. Next row, 46 times negative 3 halves plus 30 times negative 2. And then 46 times negative 1 half plus 30 times 1. And last row, 96 times negative 3 halves plus 68 times negative 2. And 96 times negative 1 half here plus 68 times 1. Good. Now I'm going to simplify them. Okay, sorry, there was a mistake. I accidentally, from this line to this line, changed it to a negative. It should be positive, so it actually should be positive 3 halves, so these should all be positive 3 halves here. Okay, so then once I simplified all of them, I got 7, 15, 0, 20, 15, 14, 9, 7, 8, and 20. And then, remembering this will give me, this will give me G-O space T-O-N-I-G-H-T, which now I can decode. Okay. So here, you're going to use the table at the beginning of the lesson to assign a number to each letter in the message seeker code. Then you're going to code the message with the matrix, and you don't have to decode it. You can use it for practice, but I'm going to just check to make sure that the matrix is coded properly. Okay, you should have gotten 34, 58, 57, 78, 65, 90, 9, 12, 27, 46, and 5, 10. If you got that right, you can get started on your homework. If not, here's your explanation. Okay. So for each one, I assigned them the numbers. Technically, it wouldn't matter, but because it told you to use the table at the beginning, I assigned each of them a number based on this table that was in the beginning of our lesson in the day. Okay. So S is 19, E is 5, C is 3, R is 18, E is 5, T is 20. The space is 0, C is 3, O is 15, D is 4, and E is 5. Okay. And then since I'm going to multiply it by a 2 by 2 matrix, I needed to make sure that there was only 2 columns as well. Okay. So then I wrote them in that order: 19, 5, 3, 18, 5, 20, 0, 3, 15, 4, and then 5. Since it ended on an, there's only an odd amount, I just put 0 for another space there. Okay. Then I multiplied it by my coding matrix, which is 1, 2, 3, 4 here. And then I multiply each row by column. So this is this row and the first column. First row, second column. Second row, first column. Second row, second column. Third row, first column. Third row, second column. Fourth row, first column. Fourth row, second column. Fifth row, first column. Fifth row, second column. And then last row, first column. And last row, second column. Then all I did is I simplified, right? 19 times 1, which is 19, plus 5 times 3, which is 15. 19 plus 15 gave me that 34. Okay. And then I just kept simplifying them until I got this, right? If somewhere it didn't match, right, just check your numbers to make sure the numbers were correct. Maybe type it into the calculator to make sure your simplifying was correct. Okay. So that's it for today. Have a great rest of the day. Bye, guys.